Right, register done, let's do this. Okay. Right.
Oh, what is that? We looked at it. Something. Like once upon a time.
Good morning, everyone.
Right. Okay, so the previous question, right, thanks guys, let's go 25 minutes please. Okay, it said, we worked out, okay, what is the question? 7% level, it was significant, right? Okay, so we had a critical Z scores of negative 1.81 and 1.81, right? That's what we were at 7%. The working hours, and we've realized it has to change working hours. Right, the next good question created a bit of confusion. Okay, so it says here, 17 hours a week that would cause one need to adjust to current working conditions if the significance level remains at 7%. Okay, so guys, mu can't change. Okay, so we've got to figure out what would be the two levels that x bar has to be. Okay. From the sample can change, but the existing value of mu can't change. You with me? From the sample. So, what's going on in this question? They're saying, right, there was an existing belief that mu was equal to, what was mu again? From the previous question? Average working hours, 49.5 hours per week, right? Okay, so mu is still there. Okay, this axis is still x bars. Okay? And they still want a 7% two-tail test. Okay, right. So we want each of those areas to be 3.5%, right? Okay. Right, we still know what is sigma? 4.8. Okay. That should just okay. And the question is, what must the mean of a sample be where she's got a problem now with the test, with the thing? You with me? Okay. So where will she have a problem? On the boundaries of that, right? Capish? Does that make sense? That's where we're looking for where x bar, where the sample mean will have to be for there to be a problem with what a person's working hours are going to be. So I've got to figure out both of those boundaries. In the previous question, we figured out the Z scores for this. So let's use those again. What were they? 1,81, wasn't it? Okay, in the previous question, we worked out that for a 7% critical test, two-tail test, the critical values were 1.81, right? So what we're saying is, there will be a problem if the Z scores are 1.81 or negative 1.81. Does that make sense? Okay, the Z scores for x bar. Give me a favor, okay. Does that make sense? I think help must be like to go down there and there's just a million people need gloves. Okay. Thank you. Okay. And I just, I've had this conversation beforehand. About why do we need to do this? Has there ever been a place where people are like, oh my god, 50 people died today because the leaves had piled up so high, okay, they couldn't walk or breathe. There's something called winter and nature which will eventually take care of it. What's that? There's some leaves lying around. Okay, right, okay. So we've got all of these parameters, right? Okay. So now what? Well, we're working with the hypothesis testing formula, which says, okay, that Z, remind me of the formula, is equal to x bar minus u sigma over root n, am I right? Like so. Okay. Right. So we're going to have to figure out x bar, right? For plus or minus negative 1.81, right? Okay. So I'm going to have, okay, I like to manipulate formulas. Z sigma over root n, okay, what's it going to be? Plus mu is equal to x bar, right? So the Z could be, you're going to have two answers, right? So it's going to be plus or, does this make sense though, guys? Okay, mu is fixed, it's x bar that we're looking for. A lot of you thought we were working with mu. And as I said, it takes a lot of time for this stuff to sink in. Plus minus 1.81, 4.8, what was n again? 40, yeah? root 40 plus 49,5. Right. Okay. Those are going to be your critical x bar values, if you like. Okay. So, if you use that in your calculator, do the positive one for me, and do the negative one for me. Okay, the negative one for me. You got it? Okay. Yeah, let's get you two decimal places.
63,24.
The positive one.
Yeah.
And the negative one? Did you do that one as well?
I did the positive.
You did the positive. Okay, so anyone have the negative one?
48,13.
48,13. So now let's think about it, right? You get, those are the working hours. Okay, am I right? That one seems very high.
It's 50,87.
Okay, I think you use 50, yeah, that's too high. Okay, those, and this is where you can do little checks, guys. What should happen? There should be symmetry, right? The mu is 49,5, that's like one down, you with me? And that's 63, something's gone wrong. Okay, so you just need to, use things like that as checks, right? Okay, and what did you get?
50,87.
50,87. Did you not use the wrong Z score?
I used the right one.
Right, okay. Right, okay. So, now, what was the question, guys? The question was, when is she going to have to change her working hours? In other words, when is she too far away from what she's supposed to be working? Do you agree? Okay. So either she'll have to change her working hours if X bar is what? Well, either less than that, right? Okay. I don't care if you say less or than equal to. X bar is less than 48,13. If she's working less than that, or if she's working more than 50,87. Does that make sense? Okay. Then there's a problem with either working too much or too little. All of these questions, most of them are kind of that. Right, okay. Right, okay. There's some things you get more. Are you looking at that? Who cares? Right, okay. Are we good? No, we're not good. Fran, shook of the head. You need coffee, Fran? Yeah, I'll make you coffee at half-time. Very nice coffee from this. That's what we use all your school fees for. Okay. Coffee machines. You know, we let the left. That's in my portion, so I only bring out the weekend so you guys can't see it. Right, okay. Right. Does that make some kind of sense, right? Okay. As I say, don't stress. Right. Okay. So then, right, we're getting there. Okay. I know this was boring going to a test, especially if you did well. And I apologize, but right. A pharmaceutical company claims that a certain headache pill contains less than 300 milligrams of aspirin. Tests carried out at 120 tablets result in a sample mean of 298 milligrams with a standard deviation of sigma milligrams. Now guys, your hypotheses are not about X bar. You can never make a hypothesis about the sample. You make a hypothesis about the existing belief of mu. Okay, so as soon as you have X bar, wrong. Okay, so the existing belief and the counter belief. Sometimes I said to find the counter belief, you have to look at, to find the null hypothesis, sometimes it's easier to look first at the counter hypothesis. Okay, and what is the counter hypothesis? What they're trying to do? That is to say, they're claiming that it's what? What they're claiming? So this pharmaceutical company is saying that our aspirin contains less than 300 milligrams of aspirin. Why would they want to do that? I'm not sure. Right, but anyway, they're claiming this. Maybe more than 300 is bad. Okay. So then if that's the counter, what's the existing belief? What?
I mean, mu cannot equal.
Yes, right. Now, what's the existing belief? Mu is equal to. So obviously, does that make sense? Okay. So it's always going to be about mu, guys. And sometimes to get the counter, it pays off despondency. Okay. Anyone confused about what's going on there? Or just to try to argue, that's fine. Right, okay. Right. Or you just don't care. If a pharmaceutical company's claim is rejected at the 1% level of significance, find the largest possible value of sigma correct to 4 decimal places. Okay. So it's a bit similar to the last question. Again, I have no idea how you guys approach questions without diagrams. Okay, so maybe you're smarter than me. So now, okay, one or two tail tests. I hate to tell you this, metric finals, you get the wrong test. Okay, so, with the left tail test, right? Okay. Where is the song day?
The song. Any day, sir.
Okay, maybe tomorrow I think we'll be ready for a song by Wednesday.
A song about a peep or like?
No, the song, your famous song. Emma said you have a song or a dance.
Oh.
You have to get work on it. Okay, right. Because this class is also going to become a talent show class. Okay, we've had one great opening performance. Yeah, I think another round of applause for both of you. And some more right, okay, so now, okay, we have, what do we have? This is our hypothesis test. In our hypothesis test, what lives in the middle?
Mu.
H0 or mu in this case, right? So H0 is, mu is equal to 300, right? Okay, then we've got a 1% left tail test. So this area over here is 1%. Okay, right. So this area over here is 49%, or 0.49. Right? Okay. Then it says, okay, what are the other parameters? So we need to find out what sigma has to be. Where would x bar have to live? The largest possible value would be over here. Are you with me? So this is where they're saying x bar must be there, on the edge of that boundary. That's the largest possible value of x bar. Okay. If someone came to say 1% level, it was rejected. Okay, so it was rejected, right? So it was in that region. Are you with me, guys? It was in this region because it was rejected, right? The answer ended up being here. So in this region over here, what's the biggest value? It's over here, this red line over here. Does that make sense? Because it was rejected, x bar ends up here. Biggest value must be that boundary over there. Okay. Right, so what do I have to find? I have to find the z score that goes with it. So h of z critical is, well, alpha was equal to 1%. So h of z critical is equal to 0.49. So what's z critical? Minus 2.33.
So do we have to say h of z critical? Can we just say z critical?
Your final answer should be that. No, you don't have to that step. That's I normally don't write. Okay. So you get a z score here, a critical z score of negative 2.33, which is what we're going to be using for the sum, because that's the boundary, right? You guys with me? Okay. So I'm using our formula. The test score would be equal to x bar. What's x bar? X bar. Now I've got to figure out. What am I doing? 1% level and find the largest value of sigma correct to 4 decimal places.
X bar is 298.
X bar, no, but we've got to find the largest. Oh, yes, thank you. X bar is 6 already. Okay, we know. Okay, so what they're saying is x bar is the same, but we're changing the parameter of sigma, right? Okay, so x bar is still, what do we say? 298. Okay, it's the same survey, right? Okay, so you're going to have z is equal to x bar minus mu sigma over root n. Okay, what are we looking for? Sigma, right? Okay, so we're going to have z sigma over root n. Okay, I know you guys don't like to do this. Okay, but you just boring. Right, so then sigma is equal to x bar minus mu z over root n, right? Okay, so sigma is equal to x bar is 298. I think I'm losing the audience here, but that's okay. Okay, it's not about you. Okay, sigma is equal to 298 minus 300 z, which is negative 2.33 over root n, which is root 40. Root 120, checking your weight. Okay. Right, so what does that give you? Did you get the right answer?
0,8583.
It's 9.
9,4. Oh, 9,4.
9,4030. Okay.
9,4030.
Okay. So if that had changed to that, then it would be rejected. Capish? Okay. Alright. Right. Okay. Righty. Are we nearly done? Okay. Given that sigma is equal to, so this determines property, so this is just a normal question, right? Okay, but a lot of you are confused again with this kind of question. Okay. What's mu still equal to? Okay. In a normal distribution, mu lives in the middle, right? Okay. So I've got an x score, z score, mu is equal to 3, what is it?
300.
300. I'm trying to figure out this. It's got nothing to do with me, guys. Okay. Right. So in this question over here, okay. Right, we're going to have, okay, what do we do? I've lost complete focus. Okay, 311, eh? You happy with that? Okay, so x is equal to 300 over there. I'm looking for that region over there. Okay, what's the probability contains more than 311, right? So we're looking for the probability that x is greater than 311. Which is, I know, but it's not actually that easy. It's because your mind now is in hypothesis testing and it's in...
So do we have to show like the 0.5 minus? Because like, I'm pretty sure this is correct.
Let's just have a look. Let's just have a look. Okay. So what formula am I using? X minus mu over sigma. X is 311 minus
300.
over, probability that Z is greater than 311 minus 300 over mu, which is, over x minus mu over sigma. Sigma is 9,4. And what does that give you as a Z? What does that Z score work out to be?
1,17.
Okay. So, the table though, this is 1,17 over there. If I look it up, it's going to give me this area over here. Okay, what did that area give you? If you look up a Z score of 1,17.
0,379.
Thank you, 0,37.
90.
Okay. So the area we want will be equal to what? 0,5 minus that, right? Which is 0, we wouldn't have a lesson without you, Mira, thank you. 0,1, 2.
210.
Okay.
I was rushing.
Nearly there. Okay. Right. I'm going to do something with this test where I have to. Okay. We'll definitely start in the next test on this test. Okay. Right. Okay. Direct questions from the test.
Only be probability mass function.
And some questions. I'm going to put about 20% directly for this test. Okay. So, right. So, right. Last question. Okay. The Amargold Fuel Company claims that, okay, the additive to their fuel reduces the average fuel consumption. The other company claims that the additive has no effect, and a lot of you got confused by this. Okay. To defend their claim, the Amargold Fuel Company gathered the following information. Okay. So, what's the existing belief? The existing belief for this kind of question is either that the mu is going to be the same, or that they differ by a certain amount. Okay. So the existing belief, okay, so now we can choose what you want to make x or y. And it doesn't matter which one you choose. Okay. I tend to make the bigger one equal to x. So then and so I'm always going to have a right tail test with a question like this. Okay. You'll see in the memo, if you look at it, there's two possible answers. There's a left tail and there's a right tail. But if I pick this as x, and that as y, okay? Oh, having a little... Okay, right. Okay. Alright. Okay. So now what's the claim? What's the existing belief? Okay. The existing belief is that the additives make no difference, right? Okay. So mu x is equal to mu y, right? Okay. What is this other company? Which company is claiming what? Okay. This, the counterclaim is going to be what? That making the additive changes how much fuel is used, right? Okay. So you could say reduces. Okay. But I would simply say that it's going to be equal to, if mu x is significantly bigger than mu y, that's the counter. You with me? So I could have that. Okay. You could also set it up like this, though. Okay. Which is the same thing as if you. Okay. Let's just do one thing at a time. Okay.
This is really good.
That's not at all distracting. Anybody else need to moisturize their hands suddenly? We have 4 people in a row. Anyone else now? Moisturizer? Oh, we have 2 volunteers here. That's tremendous. Right?
Guys, my hand cream, please. I didn't think this was going to be 12.
Yeah, okay, just one more person. Right, that's it, I'm afraid. I'd like to put it on there. Right, the rest of the back, we're going to find another distributor of moisturizer. Right. Right, this is tremendous. Right, okay. So we want to, that's going to be the counterclaim, right? People watching this video, I mean, obviously, like, I hope you're on like 3 times speed. Okay, right. So, mu x minus mu y is equal to 0, right? So this is going to YouTube, by the way, the whole world's here, right? Right, I mean, let's not give me some names. Right. So then, guys, so what's going on here? Okay. These are claiming that they're basically claiming there's a significant difference, right? In one direction. So you could do it to the left, you could do it to the right, but a lot of you got confused, okay, with this whole scenario. Be consistent in your sum, okay? So here is H0, okay, in the middle, right? Your axes here are x bar minus y bar. And with the notation that I've used, it must be a right tail test. Because I'm looking to see if x is significantly bigger than y. Okay. So if you had swapped them around and called that one x and that one y, it would have been a left tail test. You with me? Okay, if I called that x and that y, then I'll be working with a left tail test. Okay, because the smaller one will be on the left. I think you swapped yours around. Okay, so just be careful, that's not uncommon. Okay, so now, okay, we are looking, it's a one-tailed test at 5% level, right? So this is 5% over here, so that's 45%, which is 0.45. Okay? So what do we first have to do in hypothesis testing questions? Figure out the critical Z score, right? Okay, so the Z crit is equal to, okay, what's it going to be? I look up an area of 0.45.
What I said.
0.1645. Thank you. Right, so that's your critical Z score over here. Is that right? What?
1.1645. So you got me wrong.
Give me 5 marks. Okay. 0.45, guys, is going to be 1.645, right? Okay. So your Z score here, stay with me for 2 more minutes, guys. Okay. Right, so there's your Z score, right? Now what I do? Now I do a test score, right? And see if it ends up in that region. Okay. So Z test is equal to, right, what's it, mu x, what's it, x bar minus y bar?
Yeah.
Okay. Minus mu x minus mu y. Am I right? Okay. Over square root of what? Sigma x squared. Over nx, not squared. That's sigma y squared over ny, right? So your test score is going to be, well, x bar was 8,1 minus 7,2, right? Minus 0, right? Okay. Over sigma x is 2 squared over n is, for x is 38 plus 2,85 squared over 35, right? Okay. And if you stick that into your calculator, what do we get?
2,08.
Okay.
1,55.
Yes.
What? Just have the calculator.
Yeah, you did. Okay, right? So Amelia, what can I, so the test score, there's the critical score, the test score is here, right? Can I reject the null hypothesis?
No.
Amelia? No. Okay, so you say there is insufficient evidence, blah, 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 you know the sentence to reject the null hypothesis? Okay, in this case, what does it mean? That they can't claim that it reduces fuel consumption. Just on, does not reduce fuel consumption. Right, well, I'm so happy that you've got to the test so excitedly, and I'm so glad that so many of you now, your hands feel suitably moisturized. Okay, that's why we're here. Right, okay, you're going to 5-minute break, and then we're going to do the next thing. Everyone got it? You switched up your X's and your Y's. Yeah, you did. Okay, you started with a left tail, but you ended up with a right tail. You got it?
Yeah, so this connected.
Yeah. Okay. It doesn't matter whether it's left or right, but you have to be consistent. Okay. Hang on. Oh. No, you can. Go. Chicken mayo, anytime. But not too early for chicken mayo.
No, it's not, sir.
That's any time.
Late in the day. Okay. Alright. Options. Record and transcribe. Stop recording. Stop.